Questions 37 and 38 refer to the following information. An instrument shows the number of revolutions per minute made by each tire of a car. In each revolution, the car travels a distance equal to the circumference of one of its tires. The circumference of each tire is equal to 2 pi r, where r is the radius of the tire. Question 37 reads, if the radius of each tire on Maria's car is 0.3 meters, what is the approximate speed of Maria's car to the nearest kilometer per hour when the instrument is showing 779 revolutions per minute? Well, the first thing I want to calculate is how much the car travels per revolution, one revolution, right? And that's going to be the circumference, right? If you think about it, one whole circumference is just basically one revolution. So our circumference, which is going to be 2 pi r, and it's going to be in the 0.3 instead of r, which is just 0.6 pi. This is our distance the car travels per revolution, or the circumference, right? So meters, so this is 0.6 meters, m for meters, per revolution. I'm just gonna write REV for revolution, okay? And I hope that makes sense. The car travels the tire travels its whole circumference for one revolution, okay? And now it says that there are 779 revolutions per minute. Okay, and so now if I have the distance it travels for, this number right here is the distance it travels for one revolution, and if I multiply this by 779, well, that's going to give me revolutions per minute. Well, that's going to give me the speed in meters per minute. And the way that works out is, well, I can cancel out the revolutions. Okay, and this is kind of like conversion factors, and you'll see later what conversion factors really are. And so if I do this, 0.6 into pi into 779, that is approximately 1468.3 meters. That's the important part, meters per minute. So m, I'm just gonna write m per minute, MIN, okay? And so now, notice how that's our speed, right? Meters per minute. But those are not the correct units. Our question is asking for kilometers per hour, okay? And so we have to use conversion factors, as I mentioned earlier. I recommend you watch a small video, maybe from the internet, on how to use conversion factors if you're still unclear. But it's quite easy, and it's used for unit conversion in these SAT questions, and they're very common, and I recommend you try learning them because it makes, or you should learn them, because it makes these unit conversion questions a lot more easier, and you don't really need to intuitively think about it. It gives you a robust method. So what I do is I do 1468.3 meters per minute. And what I'm trying to achieve is I'm trying to multiply this by fractions in order to cancel out the minutes and meters and replace them with hours and kilometers respectively. And it makes sense if I do it. So, well, I want to cancel out the minutes. So I'm going to keep 60 minutes on the numerator. And 60 minutes are in 1 hour. Okay? And so, do you see how this works out? I can cancel out the minutes because here it's on the numerator and here it's on the denominator. Okay? And now I have, if I just cancel these out right now, well, I have meters per hour, and we're halfway there. Okay? And so now I do another conversion factor, and now it's for the same thing, but it's for meters to kilometers. Well, I need to have meters, 1,000 meters, on the denominator because we have meters here on the numerator. They need to cancel out again. And so 1,000 meters is equal to 1 kilometer. Okay? And so the meters cancel out. And so what units I'm left with is kilometers and hour, right? Kilometer per hour. And that's exactly what the question is asking for. It's just that now I have to multiply 1468.3 into 60 and then divide it by 1000. Okay, so into 60 right here, into 60, and then I think 1483, sorry, 1468.3 into 60 divided by 1000, and that's approximately 88, right? They want us to the nearest kilometer, and so that's going to be 88 kilometers per hour. Our answer is 88.